Wade.
Hey, Carly.
Today, we're going to talk about hypothesis testing, which is one of the most powerful tools in statistics. So to explain hypothesis testing, I want to think back to the beginning of this series. So one of the first things we talked about was experimental design. And we talked about how we need to decide if we want to do an experiment, we need to decide how to divide our treatment group and control group. And I used the example of testing a computer science drug.
Yes, this drug I definitely wanted to be part of the treatment group.
Yes, and we said, let's just say we had 100 people in our study. And we randomly divided them into a treatment and control group. So it's important to note that they are randomly divided. That is the best way. And now it's the end of the semester. And I want to answer my original question of, does my drug work? Does this drug actually help Wade become better at computer science? So the question is, how do I do that? And let's just say that in our treatment group, the people who took the drug, their average final grade was an 85%.
Okay, pretty good.
Pretty good, right? And then the people who were in the control group, the people who had a placebo, their average grade was 83%.
Oh, close.
Close. So the question is this enough to say the drug worked? Like if I just asked you that way, would you say this drug actually worked?
I would be skeptical. It seems there's a little bit of evidence to maybe say it works, but it's a very small change. So maybe it's just random chance?
Exactly. It could just be random chance. And if we asked a bunch of people this question, do you think this difference shows that the drug works? Probably some of them would say what you said. Some of them would say, yeah, it's different. So I think it works. But we have this tool called hypothesis testing to be able to test out if this difference is what we call statistically significant or more likely to happen than just due to random chance. So there are a bunch of different hypothesis tests, and they all have different parameters and different conditions, but they all kind of follow the same formula. So with a hypothesis test, we're going to do basically the same couple of steps regardless of which test we're doing. So for all tests, our first step is to actually state our what we call null and alternative hypothesis. State our null and alternative hypothesis. And this just tells us, okay, what are we testing? And so in this case of the drug example, our null hypothesis would be, I always like to think of it as the dull, boring hypothesis of no effect. The null hypothesis would be that the drug did not work. This difference is just due to chance. The alternative hypothesis is basically what we're trying to test, that the drug worked. We're saying, no, this difference is too big to be due to random chance. And then at the end of the test, we're going to say which is more likely, the null or the alternative. The second thing that we're going to do in any hypothesis test is to calculate a test statistic. Calculate our test statistic. So we want to think about what we're expected to get and then the difference that we got and mathematically come up with a statistic to measure that. So with hypothesis tests, we're always going to assume the null is true until otherwise. So we're going to assume our drug didn't work until we have evidence that it did. And so our test statistic would basically measure this difference in terms of standard units usually. We could convert this to a z-score. And then after we have our test statistic, we can find something that's called the p-value. So the next step would be to find the p-value. And the p-value is the probability that we would get our data or something even more extreme, an even bigger difference in this case, just by chance. And if our p-value is low, if the probability of getting this difference by chance is low, then that suggests that there might be evidence of the alternative. So we would find this p-value, and then lastly, we would make our conclusion. So we would make our conclusion, did the drug work or not? Is there evidence of that? So we're going to do a lot more examples of hypothesis tests with real data so that you can nerd out with these steps to doing a whole hypothesis test. But for now, that's kind of the general format. And again, this is one of the most powerful tools in statistics, and we're going to see it through a ton of examples in this series.
Can't wait to nerd out with more hypothesis testing.